Welcome back to the deep dive. Today we are tackling a subject that I think everyone who has ever used an AI chatbot has experienced, usually with a mix of absolute awe and then moments later, complete and total frustration.
Oh, yeah.
You know that specific moment I'm talking about? You ask a really smart friend a question, or in this case, a really smart computer program, and they answer with such absolute unwavering confidence that you just instinctively believe them.
It's the confidence that gets you. It really is. It's that authoritative tone.
Totally.
And then you find out 5 minutes later, usually after you've already repeated that fact at a dinner party or put it in an email to your boss, that they were completely making it up.
Exactly. That is the quintessential experience of the hallucination. It's the mansplaining as a service problem. We have these large language models, or LLMs, that are incredibly fluent. They sound like experts, but sometimes they just drift off into fantasy land.
Right. They prioritize sounding good over being right.
Yes.
And for a long time, the industry standard solution to this, the Band-Aid, really has been something called a RAG-J.
RAG, Retrieval-Augmented Generation.
That's the one?
Which, just to set the stage for anyone who hasn't been deep in the AI weeds, is basically giving the AI a textbook, right? It's like saying, hey, don't just guess based on what you remember from your training. Go look it up in this database first.
Precisely. It's connecting the creative brain of the AI to a factual library.
Hey,
But today, we aren't just talking about RAG. We are diving into a paper that argues standard RAG, the way everyone is doing it right now, is actually kind of, well, dumb.
Dumb's a strong word.
Or at least it's a blunt instrument.
Okay, I can see that. The paper is titled Self-RAG, Learning to Retrieve, Generate, and Critique Through Self-Reflection.
And that self part there is doing a lot of heavy lifting.
It really is.
Yeah.
So the mission for this deep dive is to unpack the methodology behind this. How do you build an AI that doesn't just blindly look things up, but actually has an internal monologue to decide if it needs help?
And then critiques its own answer before showing it to you.
It's like giving the AI a conscience.
Or at least a very strict editor living inside its head.
A very strict editor is a great way to put it.
Yeah.
But before we get to the solution, we really need to hammer home the problem. You mentioned standard RAG is a blunt instrument. I always thought RAG was the holy grail. You ask a question, it searches a database, it gives an answer based on that data. What's the issue there?
The issue is what the researchers call indiscriminate retrieval. I mean, think of it this way. Imagine you have a friend, and no matter what you say to them, literally anything, they feel compelled to run to the library and check a reference book before responding.
Okay, I can see that being annoying. And fast.
So if you ask, what is the capital of France? They run to the library. That's helpful. That works.
Oh, sure.
But if you say, hi, how are you? They also run to the library to look up the definition of health and greetings in the dictionary before they say, I'm fine.
That sounds exhausting.
It is.
And incredibly inefficient.
It is. And it actually hurts versatility. The paper points out that standard RAG retrieves a fixed number of documents every single time, regardless of whether the question is, what is the boiling point of water? Or
write me a poem about a sad robot.
Exactly. And for the poem, looking up Wikipedia articles about industrial robotics might actually kill the creative vibe, you know?
Right. It just introduces noise.
It does. The paper calls this hindering the versatility of LLMs. Sometimes the retrieved info is off topic and the AI gets distracted. It tries to shoehorn these dry, technical facts into a creative prompt, and you just get a mess.
But wait, let me play devil's advocate for a second. Isn't it better to have the information and not need it than to need it and not have it? Why is noise such a big deal for a supercomputer? Can't it just ignore the bad search results?
You would think so, but current LMs are surprisingly susceptible to what we call distraction, or the lost-in-the-middle phenomenon.
Lost in the middle.
Yeah. If you feed an LLM 5 documents, and 3 of them are irrelevant garbage that the search engine picked up by mistake, the model doesn't always know they are garbage.
Oh.
It treats them as context. It tries its best to make sense of them.
So by trying to be helpful, the standard ARGA model is actually confusing itself.
Yes.
It's like a chef trying to include every ingredient in the pantry just because they're sitting on the counter.
That's a fair analogy.
Yeah.
And it leads to the second major issue, which is unverified output. Just because standard ARGI retrieves the right document, there is absolutely no guarantee the model actually uses it correctly.
Right, because standard models are trained to predict the next word, not to be fact checkers. This is the I'm going to ignore the instructions problem.
Correct. They might ignore the evidence entirely, or worse, hallucinate something that contradicts the evidence they just found.
So this is the core problem.
This is what they set out to solve.
Yeah.
The authors of this paper wanted a framework where the model explicitly asks itself, did I actually use the source provided, and is this source actually relevant?
Okay, so that sets the stage perfectly. We need a model that can think about its own thinking. This is where we get into the self-AG solution. The core concept here is this internal monologue. But let's get specific. How on earth do we get a computer to introspect? We aren't talking about actual consciousness here.
No, definitely not consciousness. It comes down to something called reflection tokens.
Reflection tokens. Okay, unpack that. Because when I hear tokens, I think of the little chunks of text the AI reads and writes.
And that's exactly what they are. Imagine you are writing an essay, but instead of just writing the final draft, you are allowed to write notes to yourself in the margins with a red pen.
Notes like, I need to double check this date or this paragraph is weak, that kind of thing.
Exactly that. In the world of this paper, those red pen notes are special tokens. The model is trained not just to generate the text you see, but to generate these hidden code words, these tokens that signal what it's thinking.
So it's printing out its own report card as it writes.
That's a perfect analogy. But I want to get a little technical for a second so we really understand the mechanism. You asked how we get it to introspect.
Yeah.
They didn't build a separate brain or a secondary neural network to do the thinking. They simply expanded the vocabulary of the model.
Expanded the vocabulary. I mean, they just added new words to its dictionary.
Precisely. Alongside apple, run, sky, and they added these special tokens like retrieve, Israel, Isup, and Isuse.
Okay, so to the model. Is-rel, which I assume stands for is relevant, is just another word it can say.
Correct. But during training, they taught the model a very specific grammatical structure. The rule is you cannot just generate a sentence. You must generate a sentence and immediately follow it with a critique token.
So it's forced punctuation. Sentence, then grade. Sentence, then grade, over and over.
Yes. And because it's part of the standard generation stream, the model attends to its own previous output to determine that grade. So if it writes, the sky is green, and the retrieved document says the sky is blue, the probability distribution for the next token shifts. The model is statistically more likely to predict Isup unsupported because it recognizes the mismatch in its own context.
That's fascinating because it implies the model knows it lied. If it can accurately predict the token unsupported, it recognizes the error, yet it wrote the error anyway.
That's a deep philosophical question about LLMs, isn't it? But functionally, yes. The generation head might output a hallucination, but the critique head, which is the same head, just looking at a different task, catches it.
And the workflow allows the system to catch that token and say, whoa, let's not show that to the user.
Exactly that.
Okay, I want to walk through this methodology step by step because the paper really breaks this down into a process that feels very logical. It happens in a cycle, you said.
A cycle of retrieve, generate, critique.
And crucially, it happens adaptively. It's on demand.
That's the key.
So, step one, the decision. To retrieve or not to retrieve.
Right. This directly addresses that versatility problem we talked about.
Yeah.
When you give the self-RAG model a prompt, the very first thing it does before writing a single word of the answer is predict a retrieve token.
It's essentially asking itself, do I know this? Or do I need to look this up?
Yes. It predicts retrieve. Yes, or retrieve no. If you ask for a creative poem, it should ideally predict retrieve no and just use its internal creativity.
But if you ask who won the Super Bowl in 2024, it should predict retrieve.
Yes. Absolutely. And the paper mentions there's even a retrieve continue option.
That's right.
Which is for when it's in the middle of a long answer. It might say, okay, I've used the first document enough, but I'm not done explaining. I need to keep looking at this evidence, or maybe even I need to check a new source. It allows for multi-step reasoning.
So it's not just a one-time decision at the start. It's checking in with itself constantly.
Exactly. It's checking at the segment level, usually every sentence or clause. This effectively solves the indiscriminate retrieval problem.
It only goes to the library when it actually needs to.
Right.
Okay, so let's say it decides, yes, I need help, I need to retrieve. That moves us to step two.
Step two is where things get a little sci-fi. It's parallel processing and generation.
Parallel processing, so it's doing multiple things at once.
When the model decides to retrieve, it doesn't just grab one document. It calls the search engine the retriever and pulls multiple documents, let's say the top 10 relevant paragraphs.
Okay, standard RAG does that too. It creates a big context window with all the search results. What's different here?
Well, standard RAG usually jams all those 10 paragraphs into one big prompt and just says, figure it out.
Right.
Self-RAG does something really different. It processes the prompt plus document A and generates a potential answer. At the same time, it processes the prompt plus document B and generates a different potential answer, and so on for all the document.
Oh, wait. So if it retrieves 10 documents, it's basically writing 10 different drafts of the next sentence simultaneously.
Conceptually, yes. It creates an array of possibilities based on the different sources it found. It is, in a way, exploring the multiverse of possible answers.
That sounds incredibly thorough, but also like it would create a mess of options. If you have 10 drafts of a sentence, how does it know which one to pick?
And that brings us perfectly to step 3, the critique phase. This is where the model puts on its critic hat.
The 3 critics. I love this part of the methodology because it really delineates what quality means. It's not just, is it good? It's specific.
It is. The model evaluates its own generated drafts using 3 specific criteria, which are, again, these special reflection tokens.
Let's go through them. The first one is IceRel.
IceRel stands for is relevant. This is the first filter. The model looks at the document it retrieved and asks, is this document actually talking about the topic the user asked about?
This seems basic, but it's huge. Search engines give you bad results all the time.
All the time. If you ask about Python, the coding language, and the retriever brings back an article about Python the snake, the model generates an ISRel irrelevant token.
And that basically tells the system, ignore this path. This is a dead end.
Precisely. It filters out the noise before it can contaminate the answer. It acknowledges that the retriever isn't perfect.
Okay, so that's the first check. Next up is ICEP. And the paper describes this as the hallucination killer. This seems to be the most important one.
It is a heavy hitter, for sure. ICEP stands for is supported. This is the critical check for factuality. The model looks at the sentence it just wrote, remember those parallel drafts, and compares it to the document it used. It asks, does the document fully support what I just wrote?
So if the document says the sky is blue and the model wrote the sky is green, ICEP would flag that.
Immediately. It would output ICEP no support, or maybe ICEP contradictory. But if the model wrote the sky is blue, it outputs ICEP fully supported.
This forces attribution. It's holding the model accountable to the source text.
It's the difference between guessing and citing. It ensures that if the model claims something as a fact, it can point to the specific sentence in the document that proves it. This is solving that unverified output problem we started with.
Okay, and finally the third critic, ICEUs.
ICEUs. Is it useful? This is more general quality check. You could have a sentence that is relevant and supported by facts, but if it doesn't actually answer the user's question, it's not useful.
Right. If I ask, how do I bake a cake? And the model gives me a fully supported, relevant history of the milling of wheat.
That would get a low ICES score. It's factually correct, but it's not helpful. It's just pedantic.
So we have these parallel drafts, and each one now has a report card attached to it.
Yeah.
It has a score for relevance, support, and usefulness. Now we need to make a final decision. Step 4.
Step 4 is the selection phase, or what they call tree decoding.
Tree decoding. Okay, walk us through that. How does it pick the winner?
Well, imagine those 5 or 10 drafts of the sentence. The model looks at the scores. It creates a ranking. Draft A has a perfect score on support and usefulness. Draft B is supported but irrelevant. Draft C is just a hallucination.
It's like a survival of the fittest for sentences.
Exactly. It uses a segment-level beam search. It picks the best draft, the one with the highest combined score from the critique tokens, keeps that one, discards the rest, and then moves on to generate the next sentence.
And then the whole cycle starts again.
The whole cycle starts again. Retrieve, generate, critique, select, sentence by sentence.
That is incredibly robust. It feels like slowing down the process to actually think, rather than just blurting out the first thing that comes to mind. But this begs the question, how do you teach a machine to do this?
That is the million-dollar question, isn't it?
I mean, writing millions of these critique tokens by hand sounds impossible. You can't hire humans to annotate every sentence on the internet with IceRel and ICEP.
You can't. And that was the big challenge in the training section of the methodology. Manual annotation is just way too expensive and slow. So they used a process called knowledge distillation.
Distillation, like with whiskey.
Sort of. It's basically a teacher-student model. They used a very powerful model, GPT-4, to teach a smaller, more efficient model.
Okay, but I have to stop you there. If GPT-4 is the teacher, aren't we just inheriting GPT-4's hallucinations? If the teacher is wrong, the student is wrong. Why not just use GPT-4 for everything?
That's a very valid skepticism. And there are 2 big reasons. First, cost and speed. GPT-4 is massive, and it's expensive to run. You can't run it locally on your laptop easily.
For sure.
But second, and more importantly, GPT-4 is significantly better at evaluating text than it is at generating it from scratch.
It's easier to grade an essay than to write one.
Exactly. So they prompt GPT-4 to act specifically as a critic. They feed it a query, a document, and a response, and ask, does this response rely on the document? They don't ask it to write the bio. They ask it to check the bio.
And they do this millions of times.
They generated about 150,000 instances. This creates what they call the golden data set. They then take a smaller, cheaper model, in this case Llama2 7B, and train it on that data set.
So they're basically compressing the wisdom of GPT-4 into a model that can run on much cheaper hardware.
Exactly. They train two distinct components. First, the critic model, which learns to purely predict those reflection tokens.
Okay.
Then they use that critic model to annotate a massive corpus of regular text to train the generator model.
Wait, distinguish those for me. Why two models?
The critic model is the specialist. It only knows how to grade. The generator model is the chatbot you actually talk to. By using the critic to annotate the generator's training data, the generator eventually learns to mimic the critic. It sort of internalizes the critic's voice.
It internalizes the superego.
Ideally, yes.
Yeah.
By the end of training, the generator doesn't need the critic anymore. It can predict its own critique tokens during inference. It's self-contained.
That is fascinating. It's just supervised learning. It's just learning patterns.
And this is a key distinction the paper makes, compared to something like RLHF reinforcement learning from human feedback.
RLHF is what was used to train ChatGPT, right? That whole system.
Yes. RLHF is incredible, but it's really complex. It requires a separate reward model, complex optimization loops like PPO. It's notoriously unstable and hard to tune.
And expensive.
Very. Self-RAG, by contrast, is just standard text prediction. It's supervised learning. You're just predicting the next token.
Yeah.
The magic is that the next token happens to be a complex self-evaluation. It's so much more stable and cheaper to train.
So they built a cheaper, more stable way to get a model to fact-check itself. That's a huge win.
It is. But there's another feature that comes out of this training method that I think is one of the coolest parts of the paper. It addresses that issue of control.
Control, what do you mean?
Yes. Usually once a model is trained, it is what it is.
Yeah.
You get the personality you beat for. If it's trained to be formal, it's formal.
Right.
But self-RAG offers inference time control.
The sliders.
The sliders, exactly. Because the model outputs these discrete tokens, relevant, supported, useful, you can actually mess with the map after the model is trained, during that decoding phase we talked about.
Explain that. How does the user control the personality of the bot?
Well, let's say you're building a medical advice bot. Accuracy is completely non-negotiable. You cannot have hallucinations.
Right. You don't want the bot making up a dosage. That's incredibly dangerous.
So during the selection phase, where it picks the best sentence from the tree, you can tell the model to weight the ISUP token heavily. You can say, if a sentence doesn't have ISUP fully supported, give it a score of -1 million.
You essentially force it to only pick sentences that are 100% backed by the documents. You kill any draft that hallucinates.
Exactly. You're applying a hard constraint. But now let's say you're building a creative writing bot. You want it to be imaginative.
Right. You want it to be free.
You can turn down the threshold for the retrieve token. You can tell it, don't look things up unless you really, really have to.
So you can make it more dreamy and less factual just by changing the weights.
Yes. And the best part is, you don't need to retrain the model. You're just changing the scoring formula at runtime. You have one model that can be a strict librarian or a creative poet just by adjusting the settings.
That is incredibly powerful. It solves that one-size-fits-all problem we talked about at the beginning.
It really does.
Yeah.
It gives developers granular control over the behavior of the AI without needing to be AI researchers themselves.
I want to zoom out a bit and look at the bigger picture. We've talked about how it works, but how does this compare to what was already out there? We mentioned standard RAG, but let's get specific.
The comparison to standard RAG is stark. I mean, standard RAG is static. It retrieves once at the very beginning. It grabs a bundle of documents and just says, good luck.
Whereas self-RAG is adaptive.
It's iterative. Think about writing a biography. If I asked for a bio of Barack Obama, standard RAG might grab his Wikipedia page.
Sure.
But if I ask for a detailed bio covering his childhood, his law career, and his presidency,
one retrieval might not be enough. The first search might miss the law career details.
Exactly. Self-RAG might write the childhood section based on the first retrieval,
Right.
then realize, wait, I need info on his time at Harvard Law. It generates a retrieve token in the middle of the answer, goes and gets new documents about his legal career, and continues.
And then it retrieves again for the presidency. So it builds the answer layer by layer, getting fresh ingredients as it cooks.
That's a great analogy. And standard RAG also assumes the documents it finds are relevant. It trusts the search engine blindly.
Right.
Self-RAG has that ISRL token. It explicitly checks. If the search engine fails, Self-RAG knows it failed and can choose to ignore the bad data.
It's skeptical. I like that. But surely there are assumptions here. What are the authors taking for granted?
The biggest assumption lies in that teacher-student phase. They assume that the critic model, the one trained on GPT-4's data, is actually accurate enough to teach the generator.
If the teacher is bad, the student will be bad.
Exactly. If the critic is wrong about what relevant means, the generator will learn the wrong lesson. The paper does show that the critic achieves about 90% agreement with human evaluators, which is very high.
That is high.
It is. But it's not perfect. And they also assume that breaking the generation into segments, usually sentences, is the right way to fact check.
Why might that be an issue?
Well, sometimes a claim spans multiple sentences. Or sometimes a nuance is lost if you chop text up too finely. But for the vast majority of factual queries, the sentence-level check seems to be the sweet spot.
Okay, so we've covered the how and the why, but now we have to talk about the elephant in the room. Or maybe the tortoise in the room.
The trade-off.
This sounds amazing. Better facts, fewer hallucinations, more control. Why isn't everyone doing this right now? What's the catch?
The catch, as is often the case in computing, is cost, specifically inference latency.
It's slower.
Much slower. Think about what standard RAG does. It retrieves once, then the model just streams out text. It's a straight line.
And self-RAG.
Self-RAG is stopping at every sentence. It's deciding whether to retrieve. If it retrieves, it's processing 5 or 10 documents in parallel. It's generating critique tokens for all of them. It's ranking them. And then it prints the sentence.
That sounds like a lot of heavy lifting for the processor.
It is. The paper's upfront about this. They discuss the essential trade-off. You are trading inference efficiency for generation quality.
So it's not the solution for a real-time chatbot where you need an instant response.
Maybe not for a casual chat where speed is the only thing that matters, but think about the use cases where accuracy is paramount.
A legal
A
assistant.
medical diagnosis tool, a scientific research summarizer.
In those cases, I don't mind waiting an extra 5 seconds if it means the answer isn't a hallucination.
Exactly. The authors argue that this trade-off is worth it for knowledge-intensive tasks. They're moving the complexity. Instead of trying to train a perfect model that knows everything, which is impossible, they are investing the compute power into a smarter process during the conversation.
It's checking its work. And checking your work takes time.
Precisely. And the data bears this out. They show that while it is heavier to run, the gains in factuality and citation accuracy are significant. It significantly outperforms ChatGPT and Llama2 chat on things like fact verification and long-form biography generation.
So you pay in time, but you get paid back in truth.
That's the deal. And in a world where AI misinformation is a massive risk, truth is a very valuable currency.
It really is. It feels like we are moving from the magic trick era of AI, where we just want to be impressed by it, talking to the reliability era, where we actually want to use it for work.
And frameworks like self-RAG are the bridge to that era. It's admitting that the model isn't magic, it's a system. And systems need checks and balances.
That's a great place to wrap up the methodology. We've gone from the blind retrieval of standard RAG to this sophisticated self-reflective cycle of retrieve, generate, critique.
It's a fascinating evolution.
So for everyone listening, next time you see a chatbot answer a question instantly, maybe ask yourself, did it think about that answer? Or did it just guess?
And if it takes a few seconds longer than usual, maybe take that as a good sign. It might just be checking its sources.
Exactly. A little introspection goes a long way, for humans and for machines.
Indeed.
That's all for this deep dive into self-RAG. It's a dense paper, but the implication that we can build AI that knows what it doesn't know is huge.
It's the first step towards genuine reliability.
Thanks for joining us. We'll catch you on the next deep dive.
Okay.
Disclaimer. We are AI avatars discussing factual research. While we strive for accuracy and hopefully use our own internal critique tokens, always verify important information. See you next time.